So imagine this. Your computer is running slow. Apps are sluggish. Browser tabs aren't responding. And the task manager or activity monitor just keeps showing higher and higher RAM usage numbers. It's not because you have too many tabs open or demanding apps running, at least not that you know of. And then it hits you. Or maybe it's been there all along. A lurking issue known as a memory leak. A memory leak usually doesn't show its ugly face immediately. It can take minutes, hours, or even days to start causing problems. For instance, not dereferencing unused objects. Circular references and object-oriented programming, especially in languages that rely on garbage collection. What next? If you're building or debugging apps, use tools like Valgrind for C, C++, Visual, and the Memory Profiler for Java, the Chrome DevTools Memory tab for JavaScript, or Instruments on Mac OS for development. Look for things like objects that aren't garbage collected, retained DOM nodes, or listeners that weren't unregistered. To test for a leak, open your app, monitor its RAM usage. Use it for 1 to 2 hours without restarting and check RAM usage again. If it keeps growing, you might be dealing with a memory leak. Let's explore some ways to tackle this issue. You're watching TechnoWatch with Malcolm Walker. Let us know in the comments if you have any other tips, or if there are specific apps that you come across that have bad memory leaks. Don't forget to like and subscribe. First, restart the app periodically. Yeah, it sounds super simple, but it's often the most effective solution. Closing and reopening the app clears the RAM usage and resets the app's memory state. So for example, if you're a heavy Chrome user, consider closing it down every few hours or overnight. Second, close unused tabs or documents. In web browsers, each open tab is like a mini separate process. So keeping a bunch of them open will naturally use up more memory. Additionally, if you're working with multiple files or projects in design or development tools, close the ones you're not actively using. Third, limit extensions or add-ons. Browser extensions and app plugins can be handy. But having too many can bloat memory. Go through your extensions and disable or remove those you don't need. Fourth, use performance monitors. Keep an eye on the apps running on your system. Tools like Task Manager on Windows, Activity Monitor on Mac OS, Top or ATOP on Linux, or the built-in browser dev tools, for example, Chrome's Task Manager, can help you see which processes are using up your RAM. Upgrade software. Often, a memory leak bug is fixed in a newer version of the app or OS, so make sure you're running the latest updates. Fifth, avoid keeping programs open overnight. Apps that run for a long time are more likely to run into memory issues. So shut them down or restart them daily if possible. Switch to lightweight alternatives. If memory issues are a chronic problem, maybe it's time to think about alternatives. If you're a Chrome user, try Firefox or Brave. If you're using Photoshop, check out Affinity Photo. And if you're a fan of heavy IDEs, consider lighter options like VS Code or Sublime when it makes sense. Finally, increase RAM. While not a direct fix for the leak itself, adding more RAM can help, especially if you frequently run out of RAM. Just keep in mind that this doesn't address the root cause, or forgetting to free memory in languages like C or C++. Sometimes memory leaks can be caused by poor plugin or extension management. These can introduce errors that lead to memory leaks. And finally, memory fragmentation in long-running applications can also play a role. Some telltale signs to look out for include a sluggish system. So you notice your once zippy Mac or PC is starting to feel sluggish. Apps take longer to open and simple tasks like scrolling through a web page become a chore. Apps using lots of RAM. The obvious sign is when a particular app is gobbling up a huge chunk of your RAM. You can monitor this with Task Manager on Windows or Activity Monitor on a Mac. Don't panic if an app uses a lot of RAM from time to time. Apps like Chrome or Final Cut Pro do that sometimes, but they shouldn't keep climbing indefinitely. Fan noise or heat. If you hear your computer's fans revving up or the CPU temperature rising, that could mean the processor is working overtime trying to compensate for memory issues. Apps fighting for limited memory might slow down or crash. Apps that don't release memory correctly can cause crashes or freezing. After using them for a while, especially if you've opened tons of tabs, files, or windows, system swapping to disk, If your system starts swapping from RAM to the disk, it means it's running out of RAM and trying to compensate by saving data to the disk. This swapping can severely impact performance, so it's another symptom to pay attention to. So what is going on here and how do we deal with it? Well, in today's video, we're going to tackle those questions head on. We'll unpack what memory leaks are, why they happen, common culprits, and most importantly, how to spot them. Stay tuned. Right, so first things first, what exactly is a memory leak? In simple terms, a memory leak happens when your program forgets to give back memory that it's not using anymore. But why should you care? Now, these can vary depending on the type of operating system and software you're using, but here are some of the usual suspects. Starting off, we have web browsers. Browsers are notorious for this, especially ones like Chrome and Firefox. Imagine opening way too many tabs and leaving them running for hours. Each tab runs its own scripts and loads up cached resources. With a ton of tabs, this can eat up more RAM than you'd expect. Next, we've got design tools like Photoshop, GIMP, Affinity Photo, or Figma. Working with tons of layers and effects in these apps can really slow things down if the program is uncareful about managing memory. Then there are development tools and integrated development environments like Visual Studio, Android Studio, or Eclipse. These are loaded with features from language servers to debuggers to giant project indexes. And while they make coding life easier, they can cause leaks if not managed well. Lastly, games or multimedia apps that are poorly coded can also have memory leaks. These apps often aim for high performance and can end up over-allocating or failing to clean up after themselves, leading to trouble. Isn't the whole point of RAM to hold data temporarily until it's needed? Well, yes. But here's the catch. When your program doesn't release that memory, it becomes unreachable. It's meaning the program can't use it, but it's also not freed up for other processes to use. This gradually eats away at your available RAM and can lead to serious performance issues over time. Think of it like having a room full of half-used tables and chairs. If nobody clears them away, eventually you won't have space for new people or tasks. That's kind of how a memory leak works. Now, before we dive into the symptoms, let's quickly look at some common culprits. Okay, now that we know what we're dealing with, let's talk about the symptoms to watch out for. Now, let's get to the bottom of why memory leaks happen. Many times they occur because of programming mistakes. Okay, so you've spotted the signs of a memory leak. For developers wondering how to detect and fix memory leaks, here are some tips. Thanks for watching.